Alright, welcome back again to another Physics 40B Explainer video. This is going to be number 16.51, and my name is Armando Avila. We're going to be going over that problem today, but before we start, we're going to go over the learning objectives. The learning objective for this week is that we're going to relate the properties of the wave, which is velocity, angular frequency, and wave number. Mostly just this part, we're just going to relate them, and that's basically what this problem goes over. So let's start the problem, 16.51, just reminding you so you do the right one. Hopefully this is the one that you've been assigned. So before we start, we're going to do a story time. So there I was in the middle of an earthquake, right? And I was so scared, so I decided to call 911, and the person who answered the phone just didn't take my call serious, and I just couldn't believe it. I guess I just didn't understand the magnitude of the situation. LOL. So funny, right? Alright, now for reals though. So earthquakes are essentially sound waves. We're going to keep this in mind for the next slide. We call them seismic waves, and they travel through the earth. It's saying that the speed of the longitudinal wave, called P waves, is 8,000 meters per second. Transverse waves, called S waves, travel at 4,500 meters per second. And a seismograph records the two waves from a distant earthquake, and it's saying if the S wave arrives 2 minutes after the P wave, how far was the earthquake? And it's saying you can assume that the waves travel in a straight line, although actual seismic waves follow more complex routes. Ignore that last sentence, it's just going to confuse you. There we go. So for the figures, I couldn't really think of any helpful figures, so then I just looked at pictures of sound waves and pictures of seismographs, and then you can see how they look very similar. So this is why the problem says that earthquakes are essentially sound waves, and because of this, that means we can use this equation to figure out the velocities. So this is our approach. This is the equation to figure out velocity. We're looking for time, so we rewrite the equation to get time. And then since we have both a P wave and a S wave, we're going to have two equations. We're going to call it TS and TP for TS wave and TP wave, right? Okay, cool. And yeah, like I said, we're going to need one for all. So like I said, we're going to have two equations, and then this is our delta time. We know delta t, it's said in the problem, it's 2 minutes, right? 2 minutes after the P wave. So delta t is equal to 2. And then you can find that difference right here. So you could do the P wave minus the S wave. And then these are the equations for the P wave and the S wave. Since they have different velocities, this is Vp and Vs. That's why they're two separate equations. And since this Tp is equal to dVp, you can put that right here. And then this one is dVs, you can put that right here, subtract them, and then this is our equation to find the change in time. But we already know the change in time, so we're going to work with this equation up here. Basically what we're going to do is find the distance, which is what the question asks for. So we factor out the d from both, and we just get 1 over v for both of them, and then we just rearrange the equation for d, and then solve it for d. So then you just literally, I think you would divide both sides by this whole thing, and then you get t over 1 over vp minus 1 over vs. And then I just switched these two so I can get a positive number, because when I first did it, I did it this way and I got a negative number and I felt uncomfortable, so I just flipped it. You can leave it like this, it's the same thing. You can't have negative distance. So this is our knowns. So our delta time is 2 minutes or 120 seconds. We want to convert units to seconds because minutes is not it's not base units. And then our velocity for the P wave is 8,000 meters per second. Our velocity for the S wave is 4,500 meters per second. You plug it into the equation, and then you get a whopping 1,230 kilometers. And that's literally it. Pretty easy, right? Good stuff, guys.